So let's say we want to hit a specific target in projectile motion. So we can be on the ground and the target can be in the air. So here's our target, and we want to launch something from the ground at a specific speed and angle such that boom, and then we hit it. Okay, so how do we figure that out? So let's kind of look at what we want here. We're not really interested in the time it takes, but here's what we do. We have a known distance, a known horizontal distance, x, and a known height. And we'll go ahead and call that h. So we know how high the target is, and we know how far away we are. And the goal is to be able to find x, or a theta. And again, we also know how fast our launch velocity. Well, in this case, we don't really know the velocity. We just know the speed, right? We just know v naught. So that's kind of what we know here. And what we want to find is the launch angle. What launch angle will make it go a distance x and hit a target h, given the fact that we do have to know how fast this is going to be. Okay, so let's write down some of the basics. We know horizontally our object is going to travel v naught cosine theta times t. Remember, this v naught cosine theta is just our horizontal velocity times time, and that gives us our horizontal distance. And we know vertically the standard position equation is just a quadratic, right? Y equals y naught plus v naught sine theta t minus 1/2 gt squared. Again, v naught sine theta is our vertical velocity, and then we're under the influence of gravity. And so this ends up being pretty easy. What we want to do is we want to get rid of time. We don't really care how long it's going to take. We just want it to go a certain distance and be a certain height when it is particularly that distance. Okay, so we're going to take this equation and eliminate time, meaning we're going to solve for time here. So t is just x over v naught cosine theta, and then we're going to substitute it in over here. Y equals y naught plus v naught sine theta, and then times t, where t is x over v naught cosine theta minus 1/2 g, and then t x over v naught cosine theta squared. And all we did was eliminate the parameter of time. This equation is going to simplify. Y equals y naught plus, okay, this is a v naught over v naught, so they go away, and then this is sine theta over cosine theta. Sine theta over cosine theta, that's just tangent theta. So it's y naught plus x tangent theta minus, this is going to be g x squared is in the numerator over 2, and then both of these get squared. V naught squared cosine theta squared. And what we have here, if you tell me, let's just say you want to hit something that's 1.4 meters tall and it's 3 meters away. Okay, so let's just put in the numbers, and you launch it from the ground. And so you want to be 1.4, that's just a 0, 3 meters, tangent theta minus 9.8 times 3 squared over 2, and let's just make up a speed. Let's say you can go, I don't know, you can launch something at 12 meters per second. 12 squared cosine squared theta. Now, this is not going to be easy to solve algebraically, but it doesn't matter. I would suggest solving it using a graph. What I mean by that is I would take this equation and put it into y1 in your graphing calculator and put that in as y2, and when you graph both of those, what you're doing is you're looking for the intersection. Right? You're asking the graph to solve the equation, when does this equal this? Well, graphically you're just finding that particular value, and then that angle will be some angle, and then you'll know exactly what angle to launch it at, so that once it's traveled 3 meters, it's 1.4 meters into the air, and boom, you know exactly what launch angle to have. Again, this is very useful to hit a specific target, a specific distance and height away, given the fact that you know the launch speed. And really, this equation, any of them could be the variable. You know, we could have x, h, and theta, and I could tell you what velocity you need to shoot it at if you have a given angle. I mean, any of these can be the variable. This is just an equation with 4 variables. As long as you know 3 of them, then you can solve for the rest. But this is pretty nice. Typically, I think these are the 3 known quantities, and then you're finding the angle, and again, the angle is some value.